next we're going to look at another graph called an order requirement graph. Now, an order requirement graph is a directed graph, so it has arrows, that shows which tasks precede other tasks among the collection of tasks making up a job. So, when you're getting a job done, sometimes certain things have to be done before other things. And to do the later things, you have to figure out how long it would take to complete doing one of those later things. You also have to think, well, how long is the thing I have to do before it going to take? And an order requirement graph shows that graphically. So let's look at an example. And these graphs are going to look slightly different. That's just to make sure all of the information is there. Example, this is from the textbook. After landing, an airplane must go through the following tasks with given order requirement graph. Task A, unload passengers, takes 13 minutes. Task B, unload cargo, takes 25 minutes. Task C, clean cabin, takes 15 minutes. Task D, load new cargo, takes 22 minutes. Task E, load new passengers, takes 27 minutes. And our goal is going to be find the earliest time that the plane will be ready for takeoff. So after it lands, how long will it take before it's ready to leave again? And some of these tasks, you have to unload passengers before you can put new passengers on. You have to unload passengers before you can clean the cabin. You have to unload cargo before you can load new cargo. And according to the textbook, you have to unload cargo. You have to be done unloading cargo before you can put new passengers on for some reason. But we have these tasks, and we're given this order requirement graph. And in the order requirement graph, I'm going to label them with large dots because I'm going to put the time in these dots. So task A, we're given, happens before task C, which happens before task E, meaning task A must be completed before task C can be started. So we're going to fill in the times here. So A is 13 minutes, B is 25 minutes, C is 15, E is 27 minutes, and D is 22 minutes. And our goal is going to be find the earliest time that all of these tasks will be completed. And to do this, we're going to list out all possible paths through this digraph. And then we're going to, so this is kind of like a brute force method. And it is a brute force method. So we're going to do list all paths through the digraph. Notice these are arrows, so we don't have to go like in this direction. We just have to start here and make our way across. List all paths, and we're going to compare times. So what paths do we have? Well, starting at A, we can go A to C to E. And I'm just going to write that like this, A, C, E. Well, what other paths do we have? Well, there's nothing else we can do starting at A, but we have B, E. There's another path. Are there others? Yes, B, D. There's another path. B, D is another path. So now we have to compare the times that these paths take. So these tasks, just to complete task E after A and C, well, how, maybe I should organize these in a chart. No, I guess I won't. Yeah, I guess I will. I should label this as a chart, I guess. So path, time. So path and time in this chart. ACE, how long does this take? 13 plus 15 plus 27. 13 plus 27 is 40. 40 plus 15, 55 minutes. How about BE? How long does that take? B, 25. E, 27. So 52 minutes. And how about BD? How long does that take? 25 plus 22. 47 minutes. So the plane will be ready for takeoff in how many minutes? So we listed all of the tasks. I'm going to fill in that blank. We listed all the tasks. We found how long it took to travel through this graph. So how long will it take for the plane to be ready? Maybe I shouldn't have erased these. I'm going to reference them. In 55 minutes, it will be ready. Now, many of you probably thought 47 minutes because it is the smallest time. But notice that we are not concerned with which tasks can be completed the soonest. We're looking for the tasks that are going to be holding us up in trying to complete this job. So if everything goes perfectly smoothly from the beginning, yes, task D will be done in 47 minutes. But after 47 minutes, we still have 8 minutes left before E is done. Because in 47 minutes, you do these 13, you do those 15, but then you only have 19 left. So there are 8 other minutes in which E has to be done. So our critical path in an order requirement graph is going to be the one that takes the most time. That's the one that's going to be holding us back the most. So let's make that a definition. Definition. A critical path in an order requirement graph is a longest path. Maybe I should mention, or should say, where the length of a path is given by the sum of its task times. So a critical path in an order requirement graph is a longest path. The length is given by the sum of its task times. So we're going to do 3 examples. And the way we're going to do these is by listing out all the paths. And in listing them out, we have to be careful that we're not jumping over any. So find a critical path. Here we have 7 tasks. Task A takes 8 minutes, B takes 6 minutes, C takes 5, D takes 3, E takes 9, F takes 4, and task G over here all by itself takes 5 minutes. What does this mean, task G over here by itself? Well, that means completing G can be done independently of all of these other tasks. So G is still something that has to be done to complete the job, but it doesn't, you don't have to finish anything else to do G, and you don't have to do G to finish anything else. But let's find all of the paths through this. So first, we can go A, B, C, D. Next, we can go A, B, E, F. Well, that's all we can do up here, but we also have task G, which makes its own path. So what are the times? Well, A, B, C, D, 8 plus 6 plus 5 plus 3 is 16 plus 6 is 22. Task G is 5, so I'll just fill that in now. A, B, E, F, 8 plus 6 is 14, plus 9, 23, plus 4 is 27. So in this example, A, B, E, F is a critical path. And we say a critical path because there may be more than one depending on how these times work out. You know, if task B took 8 minutes, then there'd be 2 critical paths. Remember, the critical path is the one that holds us up the most. It's the one that takes the most time. Let's look at another example. For those of us who are doing our work on chalkboard, on whiteboards, it'll be easy to do this next example. If you're taking notes, it might be a little more difficult because you'd have to rewrite everything. So I'll give you a moment to rewrite that while I erase this chart. So I added a task H which takes 30 minutes. So what are our paths now? Well, let's keep using the blue marker. Paths up here, we still have A, B, C, D, and A, B, E, F. A, B, C, D still takes 22 minutes. A, B, E, F still takes 27 minutes. We also have task G, which takes 5 minutes, and we have task H, which takes 30 minutes. So here we have 4 possible paths through this graph, and the, well, in this case it is the critical, heat just came on. If you hear a noise, that's heat turning on. So I just turned it off. The critical path in this case is H. So this one part of this job takes longer than anything else that you have to complete in this job. Let's look at one more. Directions will still be find a critical path. But I want to do the one I have written down over here. Find a critical path here. Let's do it in a black marker and then do the chart in a blue marker. Example. Find a critical path. So we have task A, we have task B, we have task C, we have task D, task D down here, we have task E, we have task F, we have task G, we have task H, we have task I, and let's throw extra arrows on here. Let's throw this arrow. Let's throw this arrow. Let's throw this arrow. I don't do archery. I don't think it's called throwing an arrow when you do that. It's probably another word. Shooting an arrow? Yeah, I think that sounds right. It'd be cool if I were capable at archery. 6 minutes, or 6 units of whatever time. 5, 2, 9, 3, 8, 7, 6, 7. And the directions, find a critical path. So we have all these arrows, lots of paths. We have to be careful that we don't miss a path. So we have task A with 6 minutes, B 5, C 2, D 9, E 3, F 8, G 7, H 6, I 7, in case that doesn't show up clearly in the video. So path and time. So how are we going to find these paths? Well, I'm just going to start at A and go across. A, B, C. There's a path. Can we do anything else from A? Well, yeah, we can go A, E, C. We can also go A, E, over to F. We can also go A, E, I. Can't go backwards. We have to follow the arrows. A, E, I. Okay, that looks like all we can do starting at A. What about D? Well, we can do D, E, C. We can do D, E, F. We can do D, E, I. And that looks like, yeah, that's all we can do from D. How about from G? Well, we can go G, E, C, G, E, F, G, E, I. What else can we do from G? We can go GH. Yes, we can go GHF or GHI. And that is all of them. With these, there's no immediate way to know it's all of them. You just have to be careful that you don't miss any. And one way to be careful is to just make sure you start at a vertex, and like I always try to do like going up as much as possible. So here I went A, B, C, and then when I did A, E, I kept going up when I could. I went as up as I could. D, E, C, kept trying to go as up as possible, and this order reflects that. So now we have to, our goal is to find the critical path, or a critical path. So we have to add all these numbers. We've got A, B, C, 13. 6 plus 5 plus 2. A, E, C, 6 plus 3 plus 2, 11. A, E, F, 6 plus 3 plus 8, 17. A, E, I, 6 plus 3 plus 7, 16. D, E, C, 9 plus 3 plus 2, 14. D, E, F, 9 plus 3 plus 8, 20. D, E, I, 9 plus 3 plus 7, 19. G, E, C, 7 plus 3 plus 2 is 12. G, E, F, 7 plus 3 plus 8, 18. G, E, I, 7 plus 3 plus 7, 17. G, H, F, 7 plus 8 plus 6, or 6 plus 8, 7 plus 6 plus 8, 21. G, H, I, 21 minus 1, 20 minus 1, or 20. I saw 21 minus 1 because it was 7 times 3 without a 1 on that middle one. So we listed all of these out, and now we need a critical path. So I'll just write it here. A, in this case, the critical path is not AEC. A critical path here is GHF, the one that takes the longest. So with these, listing them out, I always find is the hardest part of these. The rest, you just have to be careful when adding the numbers together. I mean, they will be numbers that are manageable. I mean, I'm not going to, you could make these numbers like, oh, this takes 28 minutes and this takes 43 minutes. I mean, come on, that's, using these numbers illustrates the point just as well as using obnoxious numbers. Now, if not better. So try the examples, and try listing them out. I'm not going to tell you how many paths there are until we go over the worksheet. So when you're making the paths, try to follow a certain pattern like I did. I always try to go up. You can always try to go as down as possible. Then you do A, E, I, A, E, F, and so on.